All right. Hello, everyone. So, to my understanding, this is going to be posted to YouTube for later students to come and look at and hopefully learn a little bit about NMR. All right. So, when I look at an NMR graph, I'm looking at four things. The first is the number of groups of peaks. So, here we have one little peak by itself. We have two a set of four peaks or a quartet, and we have three, a set of three peaks. And these peaks are going to tell us the number of unique hydrogens. So let's just add our hydrogens here to our ethanol, and hopefully you can see that these three hydrogens have the same connections. So um, they will appear the same on the NMR because in the molecule they are basically the same hydrogen, right? So these three are connected to a C that's connected to a C which has two H's and is connected to an O which has one H. And that's the same for this hydrogen, for this hydrogen, and for this hydrogen. So that's one unique hydrogen. All right. And since we have three sets of peaks, we have three unique hydrogens. So next, we want to look at the integration. And the integration is a number given for each group of hydrogens that is going to tell us exactly how many hydrogens it represents. So over here we see that this group represents three hydrogens. This group here represents two hydrogens. And this group at the beginning represents one hydrogen. And hopefully you can see this on the ethanol. This one unique hydrogen represents three hydrogens, so it's got to be this one. And obviously on tests or in the lab, you might not know which compound you're working with, so you're not gonna know. You're not just gonna see right off the bat. Oh, this represents this peak. The set of peaks represents this part of the molecule. But generally, when it's three hydrogens like this, you can say, oh, we have a methyl group here, right? Because it's three identical hydrogens. It's going to be a methyl group. And then the next thing we want to look for, the third thing, is going to be the position of the group of peaks on the graph. So we can see that this first group of peaks, we'll start over here. This first group of peaks here is about 1 ppm. Alright, and I would write that down if I were doing a problem where I was trying to figure out what this was. And then my second and third group, we'll just put them together, are both at about 3.5 ppm. So now that I know, roughly where they are in the graph, I'm going to have to pull up some, the literature values and figure out what it could be. And so my one at 1 ppm can be an amine, but we don't have any nitrogen, so we're going to cross that off right away. We know it's not an amine. It could be an alcohol. Okay, so let's write that down. We know that it could be an H attached. They could be H's attached to an oxygen, so that's possible. Or it could be an alkane, which is also possible because ethanol is an alkane. And then we want to look about 3.5 ppm for our other two peaks, and we see that once again it could be an alcohol, or it could be a hydrogen that is attached to a carbon that is attached to an oxygen, so that could be an ether, an alcohol, or an ester. It could be a halide, but we don't have any halides in our compound, so we're just going to get rid of that right now. And so that gives us that the other two peaks are going to be either the carbon or the hydrogens on the carbon attached to the oxygen, or the hydrogens attached directly to the oxygen. So if we go back, we can see that this first hydrogen, it's only one hydrogen, and it's by itself, so it's a unique hydrogen that has no other hydrogens like it, and it's either on the alcohol or attached to a carbon that is attached to the alcohol. And we can see that there is only one unique carbon that matches, or unique hydrogen that matches those specifications. And we can do the same thing for 2, and we can see that these two hydrogens are connected to this carbon that's connected to the oxygen. So this is going to be, these two are probably this set of peaks. And then the last one we know is going to be an alkane or an alcohol, but since our alcohol is already covered, it's just going to be an alkane, so we have our methyl group, right? I hope all that made sense. And so then there's one more thing you got to look for when you are doing your NMR, and that last thing is going to be these coupling of the peaks. And so what coupling is referring to is the hydrogens that in the peak, so that the hydrogens in the peak can couple with hydrogens on carbons near them. And so if we let's just draw out a little thing here, just a little demonstration. So this is another way of drawing our ethanol. And so the coupling, I said, is the number of peaks in a group of peaks, and it refers to the hydrogens that are on the adjacent carbons to a hydrogen. So that's a really confusing sentence. I confuse myself just saying it. But basically what I'm saying is that these hydrogens, so this one and this one, are represented in the coupling of like this hydrogen's NMR or this hydrogen's NMR, right? And so we can see that this series here has 3 peaks, and we're going to say the first peak is just to know something's there. The first peak is just know that there's a hydrogen there, or multiple hydrogens there, and they're part of your molecule, right? And then we are going to say any additional peaks. Peaks are hydrogens that your hydrogen is coupled with. So if we look at this first set of peaks, we have 1. So there is a hydrogen here, right? We do have this alkane over here, and then we have 2 and 3, and 2 and 3 are going to be 2 and 3. So we're saying that this hydrogen here sees this hydrogen. Oh, that's a terrible eye. Let me draw that a little bit better. Sees that hydrogen, and it sees that hydrogen down there. And so there's 3 peaks, and we can repeat this looking at the other groups of peaks. So for this first one, on the far left, there's only one peak, so we say yes, there's a hydrogen here, but it's not facing any, it's not coupled with any hydrogens on adjacent carbons. So that's just going to be this one, and then this one on the alcohol, to be clear. And then the second group of peaks, there's one, so we do have hydrogens, and they're attached to 1, 2, 3 other hydrogens, and so that's our hydrogens here. So we'll call this H1, and they see 1, 2, and 3, and they see 3 hydrogens. So that's why there's 4 peaks. So hopefully that makes sense. Just to summarize, when we looked at our NMR, we looked at the number of groups of peaks, the integration, so the number by the peaks, the position of the group of each group on the graph, and the coupling or number of peaks within each group. Alright, so let's take our newfound knowledge and just briefly look at a little bit harder example. And so here I have ibuprofen. And so right off the bat, the first thing we want to do is count the number of peaks. So 1, 2, 3, 4, 5, 6, 7, 8. So we're going to say there's 8 unique hydrogens. Next, I'm going to look at the integration. I don't have the integration here, so I'm just going to not do that. But that's what I would do if it was here. And next, I'm going to look at the positions. So we have we have a peak at about 11, 2 peaks around 7, a peak about 4, and then we have about 2.5, 1.5, and 1. And so we'll go over to our literature values, and we'll see that 11 has to be an alcohol, right? It has to be or a carboxylic acid. It has to be it has to be the hydrogen attached to the oxygen, attached to the carbon that is double bonded to the oxygen. So it has to be the hydrogen that is a carboxylic acid. Alright. And then if we look back towards 7, it could be amides, but we know we don't have any nitrogen, so it's not going to be amides. So it can be either alkenes or aromatic compounds for those 2 peaks that were at 7. And then 4 can be an alcohol or just a hydrogen attached, or hydrogen attached to a carbon that's attached to an oxygen, or and then for the 1 and the 1.5 we can have alkanes. So I know I went fast. We already kind of showed you this. Slow down if you need to, but hopefully you get what I'm going at. I just copied down where on the graph each peak was, and then I looked at the literature to see what potentially these peaks could be. So we knew that this peak here had to be the carboxylic acid, so here it is. Boom. That peak is really easy. You can see there's it's only one peak, so it's not attached to any other hydrogens. It's just that carboxylic acid. Great. Then these peaks at 7, if you'll remember, it's the aromatic and the alkane potentially, or the alkene potentially, and in this case it's going to be both. When you see 2 peaks like this at about 7, it's indicating the hydrogens here on this on the benzene ring. We have these 2 hydrogens are identical and these 2 hydrogens are identical. So you see 2 peaks that are doublets because each of these hydrogens is also only touching the one other hydrogen. And then if we look at our peak at 4, as you'll recall, that's going to be a hydrogen attached to a carbon that is attached to an oxygen, likely. Or let me go back and just look at that real quick. Yeah. And we don't actually have one of those here, but I'm just gonna let you in. And I'm just gonna let you in. And this is, and you can know that also that's gonna apply to like here, probably because this is a methanol or a methyl group that is affected by the electronegativity of these carbons. So it's gonna pull the set of peaks further down the line. So you got to watch for that when hydrogens or when carbons are close to very electronegative compounds. They're going to get moved down the line a little bit. And so I'm running out of time here, but basically, um, these are just going to fill in the rest of these alkanes, and the probably the most important one you want to see here is this one here with a ton of peaks, and we are gonna say that one is probably right here, because this is attached to 1, 2, 3, 4, 5, 6, 7, 8 hydrogens, so it's gonna have a ton of peaks. Um, and then just one last thing before we finish up here is that you're gonna see. You know what? Never mind. No last thing. I hope this helped. Sorry, I'm out of time, but I hope this helps you do NMR in the future.